So today we talk about equivalent functions, and the best way I know how to describe an equivalent function is it's a function written as something in the first quadrant, or having an angle in the first quadrant, if you will. So what we want to do is we want to write the equivalent function for sine of 150. All right, and we know that 150 is somewhere over here. Well, we want to write a sine function that has the same y value as the value at 150. But that function has to be named such that the angle we give is in the first quadrant. So in this case, I know if I look at reference angles that 150 is 30 degrees up from 180. So 30 degrees in the first quadrant should have the same y value as the sine of 150. So we can say that sine of 30 degrees is an equivalent function to the sine of 150 degrees, if that makes any sense. Now, how's this going to help us? Well, it's going to help simplify problems of a tougher degree in a couple of days. Here's my general rule for finding an equivalent function. What you want to do is you want to find the reference angle and determine if the answer, like x or y over x or what have you, is going to be the same or have the opposite value of the value given in the first quadrant. So is it positive or negative? All right, let's move on and do a couple more examples. So I now want to find the equivalent function for the sine of 210. Again, I want to look at where I am. 210 puts me down here, and again, my reference angle is 30 degrees. So now what I want to compare is I want to compare the y value in the third quadrant to the y value in the first quadrant. Well, I know the y value in the third quadrant is negative. The y value in the first quadrant is positive. So I want these two functions to have the same y value in the end. So in order to do that, I'm going to take the sine of the reference angle, but I know that has the opposite value of the sine of 210. So in order to make them equal, I take the opposite of the sine of 30, and that will equal the same value as the sine of 210, which in this case would be negative half. All right. So now we dealt with two angles where we knew reference angles and we knew x and y values relative to the unit circle. 100 degrees we don't really know, but we want to find an equivalent function for the cosine of 100. Well, we know where 100 degrees is. It's somewhere in the second quadrant. We know its reference angle is 80 degrees. And I want to state that as a function in the first quadrant. So there's my first quadrant angle of 80 degrees. But now the question is the cosecant of 100 going to have the same value as the cosecant of 80? Well, I really don't need to know its value. I just need to know that are they going to be both positive, both negative, or are they going to be opposites? Well, since we're talking about cosecant, we're talking about a y value, and I know the y value at 80 is going to equal the same as the y value at 100 because in the first and second quadrant, y is both positive. So I can just put an equals there, and that's my equivalent function. Let's keep moving. Now I want to find an equivalent function for the tan of 135. 135, somewhere in the second quadrant, and it has a reference angle of 45 degrees. And when we talk about tangent, we're talking about y over x. So I know in the second quadrant, the tangent's negative. When I look in the first quadrant, I know that the y over x value in the first quadrant is positive. So again, I have the reference angle of 45, so I have the tangent of 45 degrees. But these values, the output values, are opposites of each other. So in order for them to be the same, I have to take the opposite of the tan of 45 in order to get the same value as the tan of 135. And we know in this case, those are both negative 1. For 240 degrees, somewhere in the third quadrant, specifically, I am 60 degrees away from 180, so my reference angle is 60 degrees. Then I have to ask myself, is the x value in the third quadrant the same as the x value in the first quadrant? It's not. It's the opposite. So I'm going to take the opposite of the cosine of 60 to get the equivalent function of cosine of 240. Now let's move on to radians. Same concept. We're going to need a reference angle. 11 pi over 6, where is that? Somewhere in the fourth quadrant. And we're looking for a reference angle. Well, pi over 6 is going to be my reference angle for that. And I'm going to start by stating we need the cosine of some pi over 6. And I have to now determine, is the x value, since we're talking about cosine, the same or opposite as it is in the first quadrant than it is in the fourth quadrant? Well, we know they're both positive. So in this case, I can just leave it as the cosine of pi over 6, and I have my equivalent function. Talking about 5 pi over 3 now in this next example. 5 pi over 3 is over pi, 2 pi over 3 to be specific. I have a reference angle of pi over 3 here. I now state my function as a first quadrant function. And now I need to know, is the sign in the first quadrant the same as the sign in the fourth quadrant? Clearly not, because the sign in the first quadrant is positive. The sign in the fourth quadrant is negative. So I take the opposite, and there's my equivalent function. Let's keep moving. A couple more. Let's go cotangent of 7 pi over 6. 7 pi over 6 is somewhere in the third quadrant. Again, we're looking for x over y in this case. We know x is negative, y is negative in the third quadrant, so we have a positive value for cotangent here. I need a reference angle, which we know is pi over 6. So I need to name this as the cotangent of pi over 6. And then I have to determine if the cotangent in the first quadrant is the same as the cotangent in the third quadrant. We know x is positive, y is positive. So yes, they are the same, and I can just put those two as equal, and I have my equivalent functions. Secant of 7 pi over 9. 7 pi over 9 is somewhere in the second quadrant, because 9 pi over 9 would be like 1 pi. I'm 2 pi over 9 away from the x-axis, so that's my reference angle. I now say this is going to be equivalent to the secant of 2 pi over 9. And I have to determine, is the x value, since that's relating to secant, is the x value in the second quadrant equal to the x value in the first quadrant? I know the x value in the first quadrant is positive. It's negative in the second quadrant. They're not equivalent, so I must take the opposite of the secant of 2 pi over 9 to have an equivalent function. Let's keep moving. Okay, so let's do a quick review. If the cosine of theta is negative 3/5, and I'm saying that theta is in between pi over 2 and pi. I want to find the cosecant of theta. Well, let's do that. This is a triangle problem. All right, actually, I should probably make this triangle somewhere in the second quadrant. So let's do that. Here's my theta value, and I'm given a cosine, so I'm given a hypotenuse and an x value of negative 3. This is a 3, 4, 5 right triangle. And I want to find the cosecant. So basically I need r over y. So that's 5 over 4. And since it's in the second quadrant right over here, I know cosecant or y value is positive. I can state that as my answer. All right, so why did we do the quick review? Just for kicks. All right, so here's what I'd like you to do now. I'd like you to write the two equivalent functions for these values, and we will talk to you tomorrow.